Welcome back. Previously, we've learned on physical and chemical change, which we discuss on the physical change and also the chemical change. We discuss on the physical change and also the chemical change. Here we have the physical change, we have the chemical change. We also discuss on the difference between the physical and chemical change, and lastly we discuss on molecules. As let's refresh our memory back again. We said the physical change are one which is not which is easily reversed, and in which no new substance are formed. Like you can see on the screen, where we have the underlined word easily reversed, and we have the other one, no new substance are formed. So we have examples there. We have the melting of solid to liquid, which I gave you example about this as the ice block. We have the freezing of liquid to solid. We have the evaporization of liquid to gases. We have the liquefaction of gases to liquid. Now we have sublimation of solid to vapor, which I have done some explanation on that in our previous classes. In our previous class, we also talk about chemical change. If you look at the screen very well, we have where it is being circled. We have easily, not easily. We have not easily reverse. We have not easily reverse, and we have new substance are formed. In chemical changes, new substance are always formed. Now, see, let's talk about the differences between the physical and chemical change. There, we've highlighted three differences between the physical and chemical change. We also talk about lastly the molecules. We talk about definition about the molecules. We said the molecules is the smallest particle of a substance that normally exists alone, and still retain the chemical properties of that substance, be it an element or a compound. So I further explained or discussed that there are some elements that independently exist alone or singly as an atom that behave as molecules. We have helium, we have sodium, we have calcium, we have magnesium, and so on and so forth. We have some molecules that are made up of other elements. We have molecules that are made up of the same element. There are some molecules that are also made up of different elements. So in our class, our previous class, we talked about molecules that are made up of the same elements. We have oxygen, we have hydrogen, we have chlorine, and we have which other one again? We have phosphorus and the like. So we have on the screen you see the examples I gave to you with the red pen there. So today we're going to talk something important, which is what the periodic chemistry. And under the periodic chemistry, we're going to talk vividly on the periodic table. But vividly on the periodic table. Now, talking about the periodic table, now the periodic table today the periodic table we enjoy using today are done by scientists. There are many scientists that contribute on the periodic table, but there's only one scientist that did the final arrangement of the periodic table. So before I go to that scientist, which will be our point of concentration, let's talk about other scientists that contribute to the arrangement or the discovering of the periodic table. Scientists like Lavoisier in 1787. We have Newland in 1865. We have Lothar Meyer and all Lothar Meyer in also 1865. So they are the scientists that did their own discovery or contribution about the periodic table. So Talking about the periodic table, this scientist or this a particular scientist Lavoisier, his own arrangement or classification of the periodic table was based essentially on metals and non-metals, or based essentially on metals and non-metals, or based essentially on metals on and non-metals. It was the Russian scientist known as Mendeleev that did the arrangement that brought about the development of the periodic law, or the development of the periodic table that brought about the periodic law, which we're going to state and also looked on today. And the year that he did all those things, or those arrangements and all those works, is in the year 1869 to 1871. So this is what we're going to discuss for this particular subject or particular topic. We talk about periodic law, talk about the periodic the blocks of elements, talk about families of elements, atomic radius, ionic radius, electron affinity, ionization, energy. Now on the screen here we have the diagram of the periodic table. We have the diagram of the periodic table on our screen. So the periodic table is arranged in such a way that we have the vertical and the horizontal axis. Also, some materials or some textbook will say we have the group and the period. Now look carefully. There's something I need to point to you. Now if you look at this diagram, we have the group. The group is from this place down here. We have the group. So now we have period. A period goes this way. The period goes this way. Now in the group we have the group 1 to group 8. Some textbook will tell you, or some materials will say we have group 1 to group 18. Some will say we have group 1 to group 0. So now if you have any material or you've seen any periodic table that indicates the group 1 to group 18, that means they are including what we call the transition metals. This is the transition metals. They are also known as the 3D block. We'll talk about them later. So these are the transition metals. They are in between the group 2 and the group 3 elements. So the transition metal, they are 10 in number. So 10 plus the group 8, making it 18. So this is the sketch, or this is the diagram of the periodic table. Now quickly let's talk on the periodic table. Now this periodic table shows the arrangement or grouping of elements in order of increasing atomic number. But remember I told you something, that Lavoisier contribution or arrangement of the periodic table was based on metal and non-metal. But it was Mendeleev, the Russian scientist, in 1869 to 1871 that developed the periodic law, which says the law states that the properties, which is what the physical and the chemical properties of an element, varied periodically with respect to their relative atomic number, with respect to their relative atomic number. So that is what he did concerning the periodic table. When he was arranging the periodic table, his arrangement of the periodic table was based on their relative atomic mass. Sorry, I made there's a mistake there. Is relative atomic mass, not relative atomic number. Was based on their relative atomic mass, or we can use it as the relative atomic weight. The relative atomic weight. Relative atomic weight. So the first the periodic law was based on their relative was based on what? The relative atomic mass or relative atomic weight. So that is what his arrangement on the periodic table was based on. So he arranged the element in increasing order of their relative atomic weight. Now the elements having similar properties kept what? Reoccurring. That is where the problem about the periodic table starts. So now when these elements in the same particular group, their chemical properties, they are what? Reoccurring. So now it gives him concern that elements are reoccurring at what interval or periodically. So that led to him, that makes him look on the chemistry on the periodic table carefully, and he starts working more on the periodic table. Now there's something about this periodic table. Mendeleev's periodic table left a lot of gaps. Mendeleev's periodic table left a lot of gaps. I repeat again, Mendeleev's periodic table left a lot of gaps. But besides that, there are some elements that are missing, but he predicted the properties of those elements that are missing in his periodic table. He predicted the properties of elements that was missing, but later he discovered those elements such as what? Germanium, sorry, elements such as germanium, elements such as germanium. We have another element as the gallium element as gallium. We have another element scandium, and so on and so forth. These are elements that was found missing on periodic Mendeleev's periodic table. But this problem led him to work on the periodic table, and later on he now made what we call the modification of the periodic law. So that is what we have as a modern periodic law. Now the modern periodic law is the basic assumption behind the modern periodic table. Now the modern periodic law states that the properties, which is what the physical and chemical properties of elements, are the periodic function of their atomic number. Their periodic function of their atomic number. So please note this: the periodic function of their atomic number. Don't forget, before I'm talking about the periodic law, we said it was based on their relative atomic weights or masses. That is why some of these elements are reoccurring. That's why some of these elements are reoccurring in a particular some of these property of these elements are reoccurring based on its arrangement on the periodic table. So that the modern periodic law was based on what? Their periodic function. Like the word I've underlined here, the periodic function of their what? Atomic number, based on the periodic function of the atomic number. So that was its arrangement on the periodic table. Now these elements on the periodic table, now if you go back to the diagram I have there, the elements on the periodic table are arranged in group and in period. Earlier on I've showed you the group. I said from up here, from hydrogen down here, the group, and along this side we have the period. So I'm going to lay more emphasis on this group and period. So we're going to talk on that. That will lead us to our second subject title, which is what? The block of element. The block of element. So let's go to the block of elements. So I have another sketch of the periodic table there, which you're seeing there. We have the group 1 to group 18 also there.